Good afternoon. We start again. We resume our lecture here, and a couple of topics I'd like to go over in this particular session here. The first one is going to be QFD, Quality Function Deployment, which you see on the screen. QFD is it stands for Quality Function Deployment. It's a Japanese technique that has also been called the House of Quality, and it's a way to translate the voice of the customer. What is it that the customer wants? How does he express his requirements to product specifications, products that we would like to produce and offer to the same customer. QFD facilitates, what does it facilitate? It helps us setting the target values for the operating and design of finished products and requirements. It's guiding what to measure when production is going on. It also provides us guidance there, and it compares, it helps us to provide competition. It helps us to provide a comparison to competition. That's also something that QFD is able to do. And let's try to think of what is it exactly going on. For a minute, what I'd like you to do is consider a product like this cell phone here. Let's say this cell phone is available and there's a good market for it, and you'd like actually to come up with a new cell phone. You'd like to come up with a new cell phone. Where would you like to actually make a start there? You could probably just grab another cell phone and produce one exactly like that. That you could do. But there could be many things that are wrong with the existing cell phone. There may be memory issues, battery life issues, features issues and so on and so forth, the size of the screen, the capabilities, does it have a camera, all those things might be an issue there. And for example, multimedia, does it have multimedia capability and so on and so forth. How do you then come up with your new cell phone? You're going to be designing a new cell phone. How do you come up with the features for that new cell phone, which are going to be not bells and whistles, but things that are going to be really useful for the customer. Let's see how we approach that task. What we are going to be doing is we are going to be translating customer requirements into requirements, and these become technical requirements that I can utilize for designing the product or for production. Thereby I will have improved production, also I will improve communication, also I'll have good teamwork between all the different people who are involved in doing this, for example, in the full value chain. I provided you here with a little website that also you can look at once you go out there and you try to do this. You will get some more details on this particular issue. Now, the QFD procedure, Quality Function Deployment Procedure, it uses a worksheet, and the worksheet itself is called the House of Quality because it looks like a house. What does it have? It has the left wall, which is the voice of the customer. I list out all the different requirements by talking to the customers. I put them down there. My goal is to come up with technical requirements of the final product. So I start with requirements of the product. I start with the voice of the customer. The customer tells me I want A, B, C, D, E, F, G, H. All these are my requirements. I'd like to convert those requirements that I got into the specification for the final product. This is my goal. So I'm now coming up with, from these requirements, I want to go to design specification. That's what I'd like to be able to do. Then of course, from design specs, I'd like to go to the manufacturing process. And then of course, I'd like to go to quality control also to make sure I go through those steps. So I first talk to the customer, I come up with design specs, then I go to technical requirements, then I go to manufacturing specification, then I go to details of the process and quality assurance. I'd like to travel all the way. To do that, I use this House of Quality structure. Let's take a look at this structure here. I've got voice of the customer, which basically are the requirements. I've got technical requirements which are put out here. These are going to be determined after examining these requirements. And here is something called the relationship matrix. I'm going to be showing that when I show you a filled out worksheet. And the interrelationships also is going to be something that I'm going to be showing to you. The customer requirement priorities also I spell out here. That's like another part of the wall. Then on this side, I do a comparison to existing products. So I may have other cell phones that I can probably get samples of, and I can use those cell phones. I can rate them against the requirements that I've discovered. I've discovered certain requirements that the customers have spelled out as their requirement. I could look at the competition's products. I could probably then do an evaluation of the competition's products with respect to those requirements that I've figured out by talking to customers. Then of course I come up with technical requirement priorities. All these are going to be more detailed as I go into a real example. Let's take one simple example. I'm in the business, I'm thinking of going to business with an energy drink. And if you get close to the screen, you'd be able to see the kind of properties or attributes that the customer would like to have in an energy drink is good taste, nutrition, visual appeal of the container. That's something that customers would also like to see. And good value for money. That's like something that customers would like to see. And to be able to do that, I find I've got to make sure for value, I've got to have good price for it. Visual appeal, size of it, not too big, not too small, probably something I can hold in my hand. And nutrition, that will be through calories, and that will be probably fat content and sodium and so forth. And of course, taste is going to be controlled again mostly by sodium, then of course calories and fat, of course. These are going to be offered by my product designers. I have customer requirements on this side, and these are going to be the product features that my designers are going to be designing. And I also find out our priorities. I find that out by really finding out what is it that the customer wants. In the eyes of the customer, something that is least important is visual appeal, something that is most important is good value, and something they would like to see also is taste and nutrition. If I offer these features with this kind of priority, my customer is going to be happy. And of course, for us, looking at the way we are going to be offering these features, I'm going to be working on price, size, calories, sodium and fat. These are going to be my design components. And I do that by looking at the priorities that I put on all of these things. And having done that, what I end up with is specs for my product. While I'm doing this, I also do something else. I look at my competition, I look at their products. Our design on the board is this. Our design on the board, present design or present offering, can be ranked as 3 out of 5 there, 3 out of 5 on taste, 3 out of 5 on nutrition, 3 out of 5 on visual appeal, and 4 out of 5 on good value. What is my competition doing? Competition A is offering a better product in terms of taste. B is offering a far better product, the best in town on taste. But competition A is not doing so well on nutrition, and B is equal to us. Competition A is going to be giving us a much better visual appeal, but that's not so important for the customer, so I may decide to stay with 3. And B also is offering something that looks better than ours, and of course then I've got good value, and there of course we are at 4, B is at 4, A is at 3. With this I get an idea how I have to reposition my current offering, and that I do that by perhaps I may like to go and match the best that is in the marketplace. And I do that, and I work out those details, and I do that. And I end up now defining my product. My product is now defined by doing this. Let's take a look at a couple of other examples also. So for building the house of quality, which is that worksheet, I identify customer requirements, I identify the technical requirements, I relate the customer requirements to technical requirements. Technical requirements are going to be design specifications. These are requirements given by the customer, these are going to be design requirements. And then of course I do evaluation of competing products to make sure that I don't spend too much and I really don't go overboard in trying to offer a feature. Then of course I do technical requirements and develop the targets that I'm going to have to meet. These are going to be my own design targets. And of course I make sure that I deploy this capability within my company. I've set my technical requirements not to deploy them within my company. For doing that, what I do QFD inside. I did my first QFD when I went from customer requirements to technical requirements. Technical requirements are my design requirements. From that, I put down technical requirements as the requirements, and then I come up with component features. What are going to be the features or the characteristics of the components? The amount of salt, sugar, vinegar, whatever it is. That I put down here, the shape of the bottle and shape of the can and all those things I put down right there. I use those the component characteristics, and I come up with process operations. So if I have to fill a bottle, I'll need a bottle filling machine. If I'm going to be using a can, I'll have to have a can filling and sealing machine. That's what I would be requiring. That I do in this step. And after doing this, I then move down to what I call the quality plan. Quality plan is basically the area where I convert my process operations into a quality plan. How am I going to be monitoring the fact that my final product comes out to be acceptable to the customer. This is what I'd like to be able to do. So I've gone through these steps. I've deployed my quality delivery capability. The first was by doing my design. The second was by selecting the components and parts. Third was by designing the process which will utilize these components and deliver the final product itself. And to monitor the process, I also need a quality plan. I've done it all, and I've gone through these 4 steps. And in fact, in this way, I've been able to deploy the capability, which is done right at the last stage. How am I going to be delivering what I promised, what I ended up doing in the QFD process? Let's take another look at another example. Someone is trying to set up a dry cleaner shop, and he knows that there are a couple of dry cleaner shops already existing in that area there. And he then does a survey of customers, and what does he find? Customers would like to have completely clean shirts or garments. They'd like to have perfect press. They'd like to have no delays at the counter. They'd like to have quick turnaround, maybe a day, maybe half a day. They'd like to have friendly service. These are the things customers are looking for, and the customers themselves give us importance, and they say no delays at the counter. Completely clean is no delay at the counter is least important. Completely clean is the top priority for them. Then of course they would like to have perfect press, and then of course they would like to have quick turnaround and friendly service, and least of all they would like to have no delays at the counter. This is what they would like to have. These are customer requirements. Then I get my gang together. I get people who know this dry cleaning business, and I bring in my workers and so on, and supervisors and so on. I ask them, if we have to deliver these things, what is it that we'd like? And they say, well, to be able to do that, we must have good training of our people. We must have clean dry cleaning fluid. We must have clean dry cleaning filters. We must have no rust in all the lines that bring in that fluid into the tank there. We must have firm pressing pads so that I get good press, and also I must have good equipment all throughout. These are determined to be the requirements that now need to go into my shop. I'm now beginning to design the shop, and I come back with specifics. What kind of training do I require? 4-hour formal training and 2 weeks of on-the-job training. That we think is really the minimum requirement to be able to do a good job there, and that's very important. And of course, how am I going to be keeping my fluid clean? By doing visual inspection every day. How am I going to be making sure that the filters are clean? Again, by doing visual daily inspection, and I clean them monthly. This is like something that I pull out as a requirement. No rust in the lines. Again, I do visual inspection, and the firm presses, firm pads on the presses, those I check by doing monthly checking and changing them by the month. Then of course good equipment. For that I've got to have some maintenance program in place. How my competition is doing. So I go out there and I sent what we call a mystery shopper. He goes to my competition. And competition, there are 2 competition I have. I have competition A and competition B. And on the characteristics that I put down there, 1, 2, 3, 4, 5, I do a rating there, and I try to find out where does competition A stand in regard to us. 1 is always the best, and 2 is worse. So I kind of decide where I should be and where competition is. This is my positioning. Once I do that, I give requirements to my company people, and after doing the technical evaluation, they kind of find a place where I should be. I should be in this position. So when I go into business, in this business, I got my technical requirements spelled out there. So what have I done here? Let me tell you a little story. The Japanese, they produce large amounts of steel, and there are very few people who would like to just buy raw steel. They would like to buy finished products. And one of the products that can be produced by using steel is ship hulls, the large ocean liners. Now this is something that Japanese started to produce. So instead of selling raw steel, they started to produce these ship hulls, and they started to sell these ship hulls. Then they found that people really had to do a lot of work to convert those ship hulls into finished ocean liners. So what they then started doing was they said, okay, let's go into shipbuilding. And there's a town in Japan called Kobe. Kobe had a big, huge earthquake. That's how they became kind of well known around the world. Kobe has a large shipyard where they take steel, then they convert it to ship hulls, and then they build these ocean liners. What they found was, what the Japanese found was, that if they offered the full finished ocean liner to a customer, to, for example, a tourism company or a country or a navy or something like that, they came down and they look at the ship, then they said, well, we want to have another flight put up there, we want some ladder here, we want that chimney to be moved somewhere else, and so on and so forth. So they wanted a lot of changes on the finished ship, and that would cost the Japanese a lot of money. They said, is there some way we could avoid this? They said, if we involve the buyers right in the beginning by doing QFD, if I could involve the customers right in the beginning, then we could only select those design features that they would require, and that's it. And we would not offer them any bells and whistles for which he is probably unwilling to pay. But it does require certain things that I've never even found out. I never did QFD before this. So they started this QFD process right there. And from that point on, of course, their business started to boom, and it was pretty clear. Right now, auto features are also determined by QFD, and there are many other products which are designed by QFD. It's also become quite popular in Japan. Now, something I have to also tell you that many features are offered in products, like for example this cell phone there. Now the cell phone is also used sometimes as a radio. Now that is fine if I want to listen to some message or something like that, but many young little kids, they could buy an FM radio for probably 1/10 the price of the cell phone, but they use the cell phone to listen to FM station. Maybe they don't want to carry another radio with them, that's why they are probably doing this. But in the old days, they used to carry a Walkman, they used to carry a portable radio, and that would do the job. They would carry a transistor. But today, this has become also a provider of music, and also it's a provider of camera and blah blah. A lot of other features are there. How many of those features really are going to delight the customer? How many of those are really a must, and how many of those are dissatisfiers, in that if they are absent, the customer would be dissatisfied? This was a big issue in product design. And I mentioned the name Ishikawa to you. Ishikawa was a Japanese expert. One of his students, his name was Kano, and Kano of course later on became a professor also. So Professor Kano, he devised a method, he devised a procedure like QFD. And I'm going to show you, I'm just going to give you a glimpse of the Kano model. This is a model that helps you find a couple of things. For example, what are the basic requirements that I must meet in the final product, because these are expected by the customer. These are basic requirements. Then of course I've got functional requirements. This is why the person is purchasing the product. Then of course there are certain latent requirements that he does not communicate to me, but he is delighted by it. For example, let's take an example of how Kano represented the different types of satisfiers in a pictorial way. He found certain things which he called delighters, certain aspects of the finished product that became delighters. For example, when you send an SMS, does this keep a record of that SMS? I know many times, we make a phone call, we would like to retrieve, some message or something there. Can I flip through back and find out, for example, what was the balance that my bank sent me in an SMS? That's going to be a feature. If it is not there, it's not such a big deal, but it's going to be delight me. There may be many others like that. So there are certain features which are going to be delighters, and they are there. There are certain features that are going to be satisfiers. If they are absent, I get dissatisfied. For example, a cell phone, for example. One of the satisfiers is remember the last dialed number, or remember the person, they recall the number that made a call to this place, to this particular cell phone. These are going to be satisfiers. These are going to be things. If they are not there, it's an inconvenience. So I kind of judge it that way. So Kano called these not delighters, but satisfiers. Then of course, he had dissatisfiers. Certain things, if they are absent there, it would be dissatisfied. For example, what we got here, we got a plastic cover for this. Could something be done by which dust would not get into these keyboards here? Because many times some people don't want to have the cover there. I personally don't mind having the cover there. In fact, initially this was not so good because I could not press on the keys properly with the help of a when the cover was also there. But could something be done that could probably protect it from dust, for example, or protect it from scratch? Could that be scratch resistant? Those are the kind of things, if they are not there, it's not such a big deal. But if their absence really, it really bugs me, and that kind of thing. So Kano was able to classify now all the different requirements. You notice when we are talking to customers to try to get our QFD done, build the house of quality, we talk to them and we try to find out for example, what are the things that people wanted. So they wanted completely clean shirt. They wanted perfect press, no delays at the counter, quick turnaround and friendly service. I'm pretty sure if you looked a little deep into this with a Kano model, we'd probably say completely clean is something that we definitely would like to have. Friendly surface might delight me. No delays at the counter, not such a big deal, but perfect press, I must have it. Quick turnaround. If it is delayed, then I'm not satisfied and so on. So I could reclassify these things not in terms of priorities, but in terms of the Kano language of delighters, basic requirements, and dissatisfiers. I could do that, functional requirements and so on. So again, I will urge you to look a little deeper into this. If you're going to be in this business, if you're going to be designing products, if you're going to be offering services, to take a look at this. I provide you here again with a little website, and look up that website and go in there. You'll be able to find a lot of tips there which basically talk about not just the QFD model, but also the Kano model, and give you a lot of things. And this can be done. I've given you another example there, and this example is coming from a guy who is going to be launching a new car. This example is for a new car launch. Now, before obviously one goes into a big venture like, for example, this offering a new car, what you'd like to be able to do is you'd like to, for example, find out what kind of people there are, what is their driving habits and so on. So he kind of, viewed the whole world to be a uniform market there. And with that, he did his survey and he put down his questions and he found certain things. He found these requirements. But what he did not do was he did not really classify people in any way. He did not segment the market. And he just wanted to see what is it that people wanted to see, people in general wanted to see in a car. So people gave this company these requirements. The car should be easy to drive, quiet riding, excellent finish, smooth riding even on rough road, excellent gas mileage, aerodynamic design, hugs the road, free from breakdowns, fast acceleration and so on and so forth. So about 12, 15 items were listed out, and in some order of ranking these were listed out. So the company thought it had done the job because it found these factors by talking to customers. They went and did some survey, floated some questionnaires, and they did a large enough survey and they were able to find that these were the ones, and they also got the ranks of them. They went into a development of the thing. The problem was this: they realized this a little later, that there are two types of drivers on the road. There are certain people who are like sports drivers. They are performance drivers. They would like to have the car really, go up and down and do all these wiggly things and so on and so forth. And there are other people who are commuters. They are practical drivers. Maybe commuters and housewives. Maybe they are carrying children in their cars. They don't want the features of a sports car in their car. But suppose a fellow really wants a sports car. Would he like a back seat? Would he like a huge trunk? He probably doesn't need any of those things. He would like probably 2 or maybe 1 seat only. That's all all he requires. So really you've got different requirements. What they were able to do was, this company went into this business and they quickly sorted the different needs that they found of the two types of drivers. There were performance drivers and there were practical drivers. What these performance drivers ranked high was fast acceleration, aerodynamic design, hugs the road. The next class of classification they gave us: easy to drive, excellent finish, quiet riding, classic styles and smooth riding. And something that was least important to the performance drivers, these were sports car drivers, were free from breakdowns, excellent gas mileage. They couldn't be bothered because they all had gas guzzlers in their garage. It protects the drivers. They didn't really care about that either. They also didn't want durability. They also didn't want many of the electronic devices and so on and so forth. And they didn't obviously want a convertible roof because that might crush the driver in case the car flipped over. And they didn't really bother about being totally maintenance free. The practical driver, on the other hand, wanted excellent gas mileage, quite opposite to what the performance driver wanted. And they wanted it to be virtually maintenance free, the practical drivers. They wanted it to be free from breakdowns, again quite opposite to what these guys wanted. They obviously wanted it to be easy to drive, durable and so on. Notice some of these things, they are common. These things are common because these are basic needs. These are functional, basic functional needs. And of course, things that practical drivers also wanted was many electronic devices, aerodynamic design, hugs the road and so on and so forth. Notice here, many electronic drivers, many electronic devices were preferred by neither of the groups. So in fact, I need not really provide a lot of electronic devices in a vehicle. It's not necessary. People don't walk into a car to have a good time. Just stand in one place and just have a good time. A lot of rock and roll and so on. They don't really want that experience while they are sitting in a car. Maybe if your car is stalled in traffic, you would like to do that. But how often are you stuck in a traffic or something like that? So in fact, the message is this: by doing the QFD process, you discover things that are neither liked by the special group, which is like your performance drivers, or the practical group, which is the commuters and housewives, for example. Certain things, none of them would like to have. Convertible, nobody wanted convertible roof. So in fact, the message was that design a car that should look probably something like this. And this is what they went in with, and they obviously came up with certain things. They also recognized in this case that there were two segments in the marketplace, and they obviously followed it through. For each of those cars, they followed it through with the proper stage by stage QFD. They started with the top, the design of the process. They came down to, from design, they came down to components. They came down to the manufacturing process, then they came down to quality assurance. They did that, and that is what is really shown there by showing technical requirements, component requirements, the process operations and the quality plan. That's how they ended up by doing this. There are other methods for improving your design. There's one area that is getting more and more important, that is called concept engineering. And here you interface with the customer in a very special way. Then there's something where you also try to take a look at the breakdowns possible in a design with a finished product, and there you do a special method, apply a special technique called DFMEA. FMEA is a standard engineering method by which you try to predict failures that can occur, and you try to take preventive steps so that this failure does not really take place. That's something that you try to do. DFMEA comes up with design failure mode analysis. This actually comes up with failure modes, the effects of the failures, the severity of the likelihood of the occurrences, and the potential causes of the failure and corrective action. These are the kind of things that you do at the design stage before you start your real design. There are some of the other tools also available, and there are the basic tools, 7 basic tools you've already seen. There are certain other tools, they are called 7 management and planning tools. I'm just going to give you a glimpse of these. There is the affinity diagram, then there is the interrelation digraph actually, that essentially gives you the flow of the decisions as they move through. Then there is something called the tree diagram that helps you organize a lot of information that is there. And the Japanese use this a lot when they are playing with different concepts. And there are other planning tools. Some of the other planning tools are like the matrix diagram or the matrix data analysis diagram. And then of course you've got process decision flow chart, and you've got arrow diagrams. These are also utilized many times when you're doing some sophisticated design. You go through these things. And these are all real shall I say, devices which are utilized by people to come up with a good design. Like I told you right in the beginning, two-thirds of quality problems in a finished product, those can be traced to the design of the final product. And design, not just the design of the product itself, but also the process that will manufacture this, and the quality assurance system that is there to monitor the process to try to come up with the final product there. This would be true for almost anything that you come up with. Any product you're looking at, many of the product defects can be traced to designs. If the design is defective, 2 out of 3 times you will end up with a problem with it. and then there are going to be custom complaints, and there could be external failures there, there could be liability suits there. And of course, if your process is not good enough, if you not really optimize the process, you'll end up with a lot of internal losses, and you'll probably have a lot of money spent on inspection. You can prevent all of these things if you do preventive things, which are things like training, use of proper design guidelines, and use of the tools that I mentioned here. And don't forget Deming's 14 points. Those are really crucial in order for us to be able to do this. One of the things these quality experts emphasized was the use of data, and that really requires you to start thinking somewhat like a statistician. Make sure that all your actions, they are driven, they are data based. So here's an example. All work occurs in a system of interconnected processes. Variation exists in all processes. No matter what you do, you're not controlling all the processes, all the factors. Therefore, there will be variation. Understanding and reducing variation, this is the key to success. This is very, very important for us to realize. There is another set of tools. Tools are not just a few. There are another set of tools, and one set of tools, these were created by the Japanese. These are called mistake proofing, by which you basically try to sort of avoid problems when, due to lack of experience or errors in identifying something or reading a sign or absent-mindedness or something, you end up with a problem there. Let's take a look at some of these things. I can design against a lot of these things by doing what we call mistake-proof designs. How do we do that? Let me directly take you to some examples. You all remember this small floppy disk which was there. We don't use floppy disks much anymore because we are all using our new friends, our CDs. Using CDs and also using what we call those little drives, the little drives there. Those are also now used in place of the floppy drive. But let's say that I'm using floppy drive. So I come back to the screen again. This floppy drive is there. You know, there's a magnetic material inside, and that requires protection from dust. This dust cover has been designed using poka-yoke. Even if you are not mindful, if you don't shut the window down, if you don't cover the thing properly, dust is going to be there. That's going to be damaging your media and the data and so on and so forth. So that's something you could avoid quite easily by having this. So this design has been done, this sliding window, it has been done. It automatically opens when you slide it inside the PC, the drive, and it comes back when you take it out. So it protects you from dust, at the same time lets you use your data. Look at this lawnmower. Notice this bar. When you cut grass using this lawnmower, you're supposed to not just manage the handlebar, but also you're supposed to pull this bar and grip it like this. You're gripping two things together. You got the handlebar, and of course you've got alongside the handlebar, you've got this bar also, and you grip the two together and you hold it like this as you're cutting grass. What it really does, if you release the bar, either it will stop the engine or it will stop the movement of the thing. So it's a safety thing. So if you let the vehicle go just like that, if you let the lawnmower run just like that, it's very possible maybe your foot will get caught or something, or it will probably run over something that you would not like it to run over. And that can happen if you're trying to control it with one hand. What you're really supposed to do when you're riding a lawnmower or when you're driving around, you're cutting grass with a lawnmower, is grip the two together. If you do that, if you grab the outer bar and the inner bar together, that's the safest position. Look at this cover here. Many of you will recognize this is the cap of your gas tank. You go out to fill some petrol in your car. Many times we misplace this cap. This cap we misplace. We put it on top of the car or on the roof of the car someplace, and then we drive off. My God, it has happened to me. It happened in Vermont. I had gone to this faraway gas station. It really was really big struggle to try to find this gas station. I was almost like empty. I was going there, but then I located this place and I went there. Then I was mad rush to get back to normal ground again. I had come up on this campground, and there was this gas station there. I wanted to return from there to wherever we were staying. And I obviously uncapped this thing. I took some gas and I forgot to put the cap there. Cap was left on the body of the car, and I drove off. And somebody told me, you know, it looks like there's some gas spilling from here. The moment you brake, there's some little splash of some liquid out of this thing. I said, oh my God, I think the cap is not on. I stopped the car, I take a look at it. Oh, sure, the cap was not there. I had to drive very carefully. I had to make sure I reached a gas station. I got something there, so they could make sure that no gas would spill out and so on. Then I got a gas cap there. So now this little string there has made it poka-yoke, foolproof. Even a fool like me would not really be missing this cap. And the same thing would happen with the basin and so on and so forth. It's very, very easy for you walk in there. You of course have this thing, and this thing will leak water. I mean, if you're mindless, if you just leave the faucets open, it will leak water. But the foolproof way is, in place of doing this, put an electronic control there. So the moment you're washing your hand, water comes up and water comes out, the spout is on, and you wash your hand. So you do away with this sort of thing, and you put an electronic sensor there that will notice the position of your hand. It will bring out water only when your hand is there. Otherwise, it does not bring out anything there. So you conserve gas. You conserve gas. You conserve gases to heat your water, and also you conserve plain water itself because it's not flowing when your hand is not there. So that's like another poka-yoke story. There are many other poka-yoke stories. There's something called Kaizen Blitz. This is almost like a gung-ho type of situation. When you go out and say that let's get some improvement done, and for that what you do is you put in an intense effort and you go through a rapid improvement process. These are like a campaign, a short duration campaign through which you try to accomplish a lot of things. These could be done like Saturday mornings or times like that. When you got a lot of clutter around, you want to put things in order. You get this gang together. You say that let's go on this blitz. Let's get this done, then we'll go and have some pizza. That's what we'll do. And that's like one great way to get a lot of things done in a concentrated mode. Creativity and innovation, these are also part and parcel of solving problems there. There are many tools which are available now that foster creativity, and there are some facilitators. They're really good in promoting creativity. That's something that you should also take a look at. Some words of wisdom from Texas Instruments. This is a company that's been very successful, and then they've brought out product after product. I'm not really sure in Nokia what kind of chip they have inside, but they'll probably have some chip, someplace something will be made out of Texas Instruments. These guys have been in business for a long time. If you go to Dallas, you'll see their massive operation there. Their mantra is this: unless you change the process, why would you expect the results to change? You want the results to change because your customer is not satisfied, he's not happy, or he's going somewhere else. What is it that you have to do? You want to obviously change the results so that his experience is different. But how do I do that without changing the process? That's not possible. So Texas Instruments people are saying, unless you change the process, why would you expect the results to change? That's like a Texas Instruments mantra. Now we move into a slightly different area. We go into quality system certification. And I'm going to be breezing through this. I'm going to be doing a bit of rapid fire in certain places because most of you can probably find a guideline. So I'm going to be giving you the highlights of ISO 9000 and also that of 14000 and US 9000. The ISO 9000 system came along when Europeans wanted to do trading with each other. The French had their own quality assurance system, the Germans had their own, and the British, they had their own, and Scandinavians, they had their own, the Italians had their own. And because they all intent on satisfying their domestic customers, they never really bothered about trying to change their quality system. It was fine. The British standard was fine, the German standard was fine for their own domestic purposes. But once they started to, when the European Union was formed, they wanted to do trade with each other to expand their economies. They said, we've got to make sure when we talk quality, we can use each other's parts. When you've got to assemble something, it's not that the British are going to produce the final finished product, whatever it were, a railroad engine or something like that, or the Germans will produce the finished vehicle completely, or the Italians will produce, or the French will produce the finished furniture completely. Nothing would be left to be done by somebody else. They said in this mode of trading with each other, we should be just specializing in doing whatever we do the best. So maybe the French will produce a lot of wine, and the Italians will be producing a lot of artistic chairs and so on. The Germans will be producing machine tools, and everybody has needs for those things. I'm sure the Germans drink wine, and the Italians also probably you have some use of the German machinery and so on. So they'll be doing some trading. They wanted to have one system, and that one system became the ISO 9000 system. So they formed a technical committee in 1987, and they launched that. And now, of course, 100 different companies, they are using ISO 9000. It's a system that really is dependent on certification. That means there is a set of auditors who come around and look at your operations, and they make sure your practices conform to whatever the ISO 9000 series of standards spells out as, whatever it spells out as standard practices. And they make sure your practices conform to the standards. How was the technical committee formed? Initially there were local committees, then there were national bodies, and the national bodies came together. They contributed members into this technical committee. TC 176 was the committee that led to the ISO 9000 drafting, and that was drafted in 1987, and it became a standard that was international. It would promote trade and cooperation. That was really the thrust. And there is a particular process through which they reach consensus. There is a systematic process by which they reach consensus. So they started with a working draft, and they came up with a committee draft, and they reviewed the draft and so on and so forth. They came up with the published standard. That was then broadcast worldwide. Initially, there were like 5 different standards given. Later on, of course, they realized that the 5 different standards, they were really, getting into a lot of bureaucratic procedures. So they simplified that later on, and one standard was put together that was for care of the environment. That was ISO 14000, and ISO 14000 also lived along nicely. Then there was ISO 10000, which was used for 10011 was used for quality systems auditing guide, and there was another one that was for manual development guide. You had to produce some manuals. In 1994, ISO 9000 was combined, and one version came along that had 20 different clauses, 20 different aspects that were audited, and guidelines had to be prepared for all these 20 different clauses, each of these 20 different clauses, and then they came up with requirements for each of these things. And the auditors used these guides, actually these standards, to audit a regular procedure, to make sure that the procedure was there. Their vision in 2000 was that they would unify these standards, and they'd come up with a standard, which they did when they came up with ISO 9000 9001, ISO 9001.:2000. This was a new quality management system that was put together, having learned a lot of things that was done with the initial set of 4 or 5 different standards. They came up with one standard, which is this one now, which put a structure in whatever a company does, and it wanted to make sure management put someone in charge. It wanted to make sure resource management was there, and product realization. So it wanted to make sure design was done right, and measurement and analysis and improvement. These were also built into the quality management standard ISO 9001. This was actually not there in the initial one. The registration was done through some people who were accredited to be registrars, and these registrars actually they were authorized to conduct these audits, and they went through certain steps, and they reviewed the process. They reviewed certain steps, and then only they would issue the registration certificate. That was done, and the registration process itself, you can again read the details there. They tell you, they walk you through a few specific steps that lead to the registration process. There's a plan for it. There's a formal plan already. You decide to go for registration. You write your QA manual. You have internal reviews to make sure you're doing what you wrote down, and you wrote down what you really ought to be doing. Then, of course, you do a systems audit. You do a mock audit internally. Then you go out and get the registration audit done, and you get your registration. And what did it do for industry? It brought about the quality policy. I can tell you for sure, my own experience is, when people were talking to me because they wanted to get the ISO 9000 certification, Many had no idea that they had to spell out a quality policy for the company. How they wanted to delight the customer, or were they really interested in delighting the customer? Were they really interested in just making money or maximizing their profit? What exactly was their reason for existing in business? That had to be spelled out. Then of course a quality system had to be there to make sure that they achieved the objectives that were set out in the quality policy. They wanted to have consistency, and consistency was achieved as a result of ISO 9000 accreditation. Then audits and reviews, these also became common after ISO 9000, and perhaps the biggest contribution that ISO 9000 made was it led to a new standard for the automotive people called the QS 9000. And I'm going to be giving you a glimpse of that. And here's one example of what ISO 9000 spells out. Inspection is a task, as you know, it is carried out by spelling out, how much you have to inspect, how often you have to inspect, where you have to inspect, and blah, blah. These things are there. And ISO 9000 really says that these are the places you ought to be doing your inspection. And let's take a look at one particular situation. If it's a fast food business, the inspection point should be cashier. And what you should be doing there is inspect for accuracy. Counter area, appearance and productivity, eating area, cleanliness, building, appearance, kitchen, health regulations. These would be the targets of your inspection if you are in the fast food business. If you are in the hotel or motel business, parking lot, is it safe? Is it well lit? What about accounting? Do you have accuracy? Do you have timeliness, timely processing of your bills and so on? Building, appearance and safety, that's very important. Main desk, waiting time. These would be again the things that you should be inspecting. These would be the things that then the ISO 9000 person will probably say, are you doing these things? What are your standards there? And show me some evidence that you're doing it. A supermarket, couple of things there. Cashiers, they check for accuracy and courtesy, of course. And deliveries, quality and quantity. These are the things that a supermarket should be doing its inspection on. So here's like something, this is some guideline that we got from ISO 9000. Once these become standard practice, of course, then your process runs very well. And you are supposed to do surveillance audit to make sure the things stay the way they are. There are certain international issues in regard to ISO 9000 that are also there. And I should also tell you that it led to this other standard called QS 9000. QS 9000 basically came along because the big automakers in Detroit, Chrysler, Ford and General Motors, what they found was that the basic ISO 9000 was not doing good enough because it did not really impact the quality of the final product. It did not really go out and look at the final product and say that I assure the quality of the final product just because I have ISO 9000. ISO 9000 was not doing that. So then these people, GM, Chrysler and Ford, they got together and they coined this new standard called QS 9000. They built it on the foundation of ISO 9000 and then they added additional customer specific requirements to it. And the result was not only autos but also auto parts manufacturers, they had to conform to the QS 9000. So the QS 9000 is built on existing ISO 9000 system, plus it adds certain mandatory additional requirements. And it also emphasizes continuous improvement that it borrows from TQM, and it moves the whole thing more toward TQM. Mind you, when I talked ISO 9000, I did not mention TQM. Of course, I did not mention anywhere, I did not mention Six Sigma. I also did not mention SPC. These were not required in ISO 9000. And these are found to be highly wanting by these auto manufacturers, GM, Chrysler and Ford. So they wanted to make sure that these things were there because these were their big headaches. They just didn't want a manual, they didn't want a quality policy and so on. They wanted good, nice, finished cars. That's what they wanted. That's what they wanted to deliver. So they coined this and they designed this total new way of looking at quality. They coined it QS 9000. These have many different requirements. So they have the basic requirements, then they have certain sector specific requirements, then they have customer specific requirements. These are added on top of ISO 9000. So you have the ISO 9000 basic requirements there, then you've got certain other requirements that have been added to it. And there are a lot of elements in it. And these assure the making of a fine car. And of course, again, this one really tells you that the foundation is ISO 9000, but on top of that, many other requirements have been added on, and certain procedures have been added. For example, new product introduction or new part approval, those are specially done this way. If you do a comparison of QS 9000 with ISO 9000, ISO 9000 is non-specific by design. It does not really worry about a particular finished product. Whereas QS 9000 is focused on automotive works, automotive manufacture. ISO 9000 is a tool geared toward all types of industries, whereas the tool for QS 9000 is really automotive parts manufacturers and the automotive industries. And there are certain differences there that again should be clarified once you go into the clauses. Quality systems area, there are certain additional requirements with QS 9000, which I show here on this slide there. I show it in the next slide when we've got additional requirements. Advanced product quality planning, this also has to be done if you're going to be registered under QS 9000. You also should be doing something called production part approval process. Before you go into production, if you've changed a part, if you've designed a new part, you have to go through this APQP procedure. And you're also supposed to measure your CPK. This is like something that was altogether not a requirement in ISO 9000, but in QS 9000, CPK is a requirement. And there are this is the 5-phase process. APQP, Advanced Product Quality Planning. This is like before you go into commercial production, you are supposed to do a product quality planning for this. And for doing this, you are really supposed to be doing this. Then of course, I've got the purchase area where I've got some controls that have to be there, and those are required. They are pulled out here, and I display them here for you. Process control area, again, here I've got extra attention paid to variations. Control of variation is a big thing, and safety, of course, is another big thing. These are all required as part of QS 9000. Inspection test area, there again, there are certain specifics which are there. Acceptance criteria for attributes, these have to be. We got to make sure we really worry about zero defects. We are happy only with zero defects, not some percent level, not the AQL, RQL type of situation. Then of course, we've got layout for inspection, functional test area, that also is spelled out in QS 9000. Certain requirements are there in the lab, besides what we call calibration requirements and so on and so forth. So there are international standards requirement, which is like ISO 9000. Then I've got customer specific requirements. And then of course, customer reference requirements, which are also there. And I produced manuals also, which are all part and parcel of QS 9000. And those are spelled out again. There are certain things required by Chrysler, certain things required by Ford, and certain things required by General Motors. These are specific and they differ from industry to industry, business to business, and those are all acknowledged by QS 9000. Implementing itself is a continuous drive, and the implementation takes you through a whole bunch of steps that you have to go through. Implementation is one of the key things that is required here is proper documentation. You got to spell out responsibility and control. You got to make sure all the controls are there, all the requirements are there. This is part and parcel. If there is a problem with quality, how are you going to be investigating that? If a customer has complained about a problem, is it a problem with the customer? If it is yes, then you follow a particular route. This is spelled out in QS 9000. This is not something that is arbitrary for a company to do or not to do. If you're going to be certified under QS 9000, you're supposed to follow this process. And they spell it out very, very clearly in their manual, in their standards. FMEA again, certain things are required and they are spelled out here. Implementing QS 9000 and conformance to specific customer requirements, these are there. What is the advantage for doing this? One big advantage is when QS 9000 audit is done, customers need not really go out to the part supplier and do their own inspection. They need not really do this. Certain improvements have been also suggested, and these are done to try to make sure it's easy for you as a part supplier, as an automotive part supplier, to do this. This is rather important for people to recognize once they are aspiring to become part suppliers to this thing. Now, you might say, what are the Japanese doing? In many cases, their quality standards exceed or excel in many of these things. So therefore, if they wanted to, just tomorrow, many of their part suppliers could really get QS 9000. So where am I today? On this march of quality, we've reached up to this point when I'm doing some DOE. DOE I'm doing for doing design development. So I've got everything in control as far as the inspection is concerned, as far as statistical process control is concerned. I've got my CPK in place, and I'm doing certain things in DOE when I'm designing for parts and products. I'm doing some designing to try to make sure I produce a good product, that's where QS 9000 registration will bring you. This is a long way from where you started. I will tell you this, that perhaps if you look at the industry spectrum, not more than maybe 2 or 3 or 4% people qualify to get QS 9000. This is something we got to keep in mind. This is not something that is so easy to get, and therefore there are very few people that reach up to this level of quality assurance. Once you have that, you can be assured about the parts that you get for your finished products. If you're getting parts from various people and they are all QS 9000 certified, you worry only about your assembly. You don't really have to worry about the quality of the parts coming in. Thank you very much. We'll continue. Thank you.